Hey guys, let's do one more example of an application for the normal distribution. We'll do example 5. So example 5 says, according to the McDonald's nutrition guide, a McDonald's sandwich has an average of 500 calories with a standard deviation of 100 calories. Assuming that the calorie content of a McDonald's sandwich is normally distributed, find the probability that a customer will order a sandwich with, and then there's A, B, C. Remember what we said in the last lesson. Don't even worry about what the question is asking. Because if you don't understand what you're reading and you don't know what the population is and the variable that's being studied and what we know about the shape and if we have a mean or a standard deviation, it's irrelevant, right? So let's extract the important pieces of information first, and then we'll get to part A, B, and C. So identify the population of interest. In this case, it's McDonald's sandwiches. That's what we're studying, the sandwiches at McDonald's. Now, what are we studying about them, right? What are we measuring? Well, it's the calorie content. How many calories does a sandwich have? So we have a population of McDonald's sandwiches, and we're measuring how many calories each sandwich has. Now it says there's an average, so let's highlight these important pieces of information. So a sandwich has on average 500 calories and a standard deviation of 100 calories. And we also know that the calorie content is normally distributed. So let's write down these important pieces of information. So we know that X our variable of interest is calorie content. We know that X is normal. And we know that the mean is equal to 500 calories and the standard deviation is equal to 100 calories. Now let's go to the question, and it has 3 parts. So A says, find the probability that a customer will order a sandwich with less than 380 calories. So think about what we were doing in the last lesson. We were making a sketch, right? What does our sketch look like? And what does calorie content look like? And then we were converting the question into mathematical notation. So, and it kind of doesn't really matter what order we do it in. So I'm just going to write down what we're looking for first. So we want to find the probability that if we select a sandwich at random, that the calorie content in A is going to be less than, so I have to use my less than inequality, 380. So let's draw a picture. Calorie content is normal with a mean of 500. So let's get our shaded area, right? Where is X less than 380? Well, 380 is to the left of 500. So X is equal to 380. We're going to put to the left. And we want to know what's the probability that X is less than 380. So less than is going to be the area to the left. So I'm going to shade the area to the left of 380. And since this is a normal distribution, we could either use the normal table. You would have to convert 380 to a z-score first and do a table lookup. Excuse me. Or we could use the calculator. I'm going to use the calculator. So we need lower, upper, mean, and standard deviation in order to use normal CDF. So lower is going to be negative infinity because we're coming in from the left. Upper is going to be my raw score of 380. And then we have to type in the mean and the standard deviation of this distribution, which is 500 and 100. So I'm going to go to my calculator. So I'm going to pull up normal CDF. My lower is negative E99. The upper is 380. The mean is 500 calories. And the standard deviation is 100 calories. Now we can paste, hit enter. And to 4 places, we get about 0.1151. So the probability that if you order a sandwich at McDonald's, the probability that's going to have less than 380 calories is about 0.1151. So part B says, what's the probability that a customer will order a sandwich with more than 675 calories? So let's write that in probability notation. So we want to find the probability that the amount of calories is going to be more than or greater than 675. So we could sketch our curve. Mu equals 500 is in the center. And we want to find the area that corresponds to x being greater than 675. And 675 is to the right of 500. And we want to find the probability that x is greater than 675, or the area to the right, which I just shaded. So we'll use our calculator. So the lower bound, where the shading begins, is going to be 675. And the upper, since we're shading towards infinity, there really is no upper, that's going to be E99. So let's pull up the calculator. So we'll pull up normal CDF. My lower is 675. My upper is E99. The mean is 500. The standard deviation is 100. So we could paste, enter. And to 4 places, we get 0.0401 if we round 4 places. So let's write that down. So my answer to the probability question is about 0.0401. So what that means is if we were to order a random sandwich from the McDonald's menu, the chances that it's going to have more than 675 calories is going to be about 0.0401. That's only a small percent chance, like a 4% chance that it would have more than 675 calories. And then let's look at part C, the last part. So we want to find the probability that the calorie content in a sandwich is going to be less than 400 or greater than 700 calories. So there's an or statement here. So it could be one or the other. So we could write it in 2 separate statements with an or in the middle. So we want to find the probability that x is less than 400 or greater than 700. So what's the probability that the calorie content is less than 400 or the probability that the calorie content is greater than 700? And we would add them together. So let's make a picture. So we have a normal distribution with a mean of 500. 400 is going to go to the left of 500. And x equals 700 is going to go to the right. And we want to shade less than 400, but we also want to shade greater than 700 because it could be either or. Now, notice in the picture, it's 2 separate areas, right? It's not one continuous area. So you have to find the area of each one and then add them together. That's all. So let's find the area on the left first. So my lower is going to be negative E99 because we're coming in from the left. And my upper would be 400. So let's do that side first. So I'm going to pull up normal CDF. I'm coming in from negative E99. And then my upper bound is 400. The mean is 500. Standard deviation is 100. We can paste. To 4 places, that's going to be 0.1587. So I'm going to label that area. So this area is 0.1587. Now I have to get the upper area. So we're shading to the right of 700. So 700 is going to be the lower bound. And then the upper bound is going to be positive infinity because we're shading to the right indefinitely. So we'll go back to the calculator. Normal CDF. The lower bound is 700. The upper bound is E99. The mean is 500. Standard deviation is 100. We'll paste, enter. And to 4 places, we get about 0.0228. So this is 0.0228. And then we have to add them. So we're going to get 0.1587 plus 0.0228. So when we add 0.1587 plus 0.0228, we get about 0.1815. And that's the probability that a sandwich is either going to have less than 400 calories or more than 700 calories. And that wraps up example 5. There was those 3 parts. So in the next lesson, we're going to move on and we're going to start percentiles and applications of percentiles.